In this video, we're going to get started with Module 8A. So Module 8 corresponds with Chapter 8 in your book, and it's a really massive chapter, so we're going to break it into two different units. The first part is going to be about rational functions, so that's what we're going to get into. But before we get into that, we need to review some things that are going to be essential in this unit. One of those things is our operations with fractions. And you guys know this, but this is just kind of, again, review. But anytime I multiply or divide, I don't need common denominators. But if I add or subtract, I do, okay? So we're gonna do an operation here with these complex fractions. A complex fraction is just a fraction inside a fraction within a fraction. So this is considered complex because I have a fraction in the numerator and another one in the denominator. So another way we can read this means divide, right? So this is really 2/3 divided by 1 3/7. Now the operations are a lot easier to do when I'm dealing with not mixed numbers. So to change this from a mixed number, I do 7 times 1 and then add 3. So that is 10/7. And remember, when I divide with fractions, I keep the first one the same. 2/3. I change to multiplication and I flip the second one. Multiplication is the easiest operation with fractions. I just go straight across. So I've got 2 times 7 is 14, 3 times 10 is 30. I can do that, or I can cross simplify as well. The benefit of doing this is then I don't have to deal with big numbers in the end. 2 and 10 go into each other. 2 goes into itself once. 2 goes into 10 5 times. I can do that diagonally. 3 does not go into 7, so I can't do that. So now I have 1 times 7 is 7. 3 times 5 is 15. So the benefit of doing that cross simplifying is I don't have to reduce in the end. I kind of reduced before I multiplied. And also then I'm going to be dealing with smaller numbers, which is a little bit easier to do in your head. Okay, the other thing we're going to need for this unit is your factoring skills. So these are a lot of the different factoring techniques that we've learned. So greatest common factor, being able to take that out. Difference of squares. So if I have two things that I can take the square root of and it's subtraction, remember that factors into their square roots, one with addition and one with subtraction. Kind of a note, the sum of squares cannot be factored. So this is something people get confused on because we have a difference of squares, but we don't have a sum of squares. So an example would be like x squared plus 4. So this cannot be factored further, okay? Now cubes, we can, because I can take the cube of a negative. So these factor into b, if I have two things I can take the cube root of, it's a plus b times a squared minus ab plus b squared. So the difference is really similar, but the signs change a little bit. So if it's subtraction, it's a minus b first, and the rest is the same with addition. Okay. Trinomial, this is if I have a 1 as a leading coefficient, okay, but it has this format. It factors into x with two numbers in those parentheses. And remember, these two numbers, they must add together to be b and multiply to be c. So numbers must add to b and multiply to c. Okay. If I have something in front of my square term that's not 1, that's where I'm going to do my reduce and bottoms up method. And then grouping is the technique I use when I have 4 terms, and I do 2 terms at a time and factor out the GCF. It is possible that things might not factor, so like this x squared plus 4 doesn't factor. When that happens, we say that it is a prime expression. Okay, so let's look at some review. Okay, so I notice I have something cubed and it's 2 terms, so I'm thinking it's the difference of cubes. So if that's the case, I need to identify what are a and b. So in this one, what is the cube root of 8x cubed? Well, the cube root of 8 is 2. The cube root of x cubed is x. B is the cube root of 27, which is 3. So I'm going to use my formula. So because it's subtraction, it's a minus b. times a squared, which is 4x squared, plus ab plus b squared. Okay, and that is done, factored. Okay, all right, second example. This is a trinomial. It's always a good idea to look for, can I take out a GCF first? There's nothing that goes into all three of those. So I'm going to jump into reduce and bottoms up. 9 times 8 is 72. So now I'm looking for numbers that multiply to be 72 that add up to be 18, which are 6 and 12. Okay, now I reduce and bottoms up. So I take that 9, I'm going to divide both by 9. We're going to reduce first. So 6 ninths reduces to 2/3. 12 ninths reduces to 4/3. And once it's still a fraction, we bottoms up. So this is going to turn into 3x plus 2 and 3x plus 4. And that is factored. Okay, this one I am noticing I have, again, squared terms. There's not a GCF I could take out of both of those, so I'm going to jump to difference of squares, right? Different, but it's not subtraction, it's addition. This is that example that does not factor. Addition with two perfect squares, I cannot go any further with that, so this would be an example of a prime expression. I cannot factor that further. This example are things I can take the square root of, but it's subtraction, so we can do difference of squares. Okay, so I know square root of this is 12x. Square root of this is 7y squared. So I have plus 7y squared and minus 7y squared. Okay, and it's just a good idea to check because this is maybe difference of squares again, but this is not something I can take the square root of, so this would be factored. Okay, another trinomial, it's a quadratic, right? Squared, non-squared, constant. GCF, there is none, so I'm going to jump into 6 times 14, which is 84. Okay, so I need numbers that multiply to be negative 84 that add up to be positive 17. So I think that's going to be 20, 21, and 4. So positive 21, negative 4. They multiply to be negative 84. They add up to be 17. Come through and divide by 6. Okay, again, reduce first. So I can divide both those by 3, so I get 7 halves. Divide both those by 2. And then bottoms up. So I've got 2x plus 7 and 3x minus 2. Okay, this last one has 4 terms, but it's still a good idea to check is there a GCF I could take out first. It looks like I could divide everything by 2. So I'm going to take out a 2 out of everything. So now I'm left with 5m to the third plus 2m squared minus 45m minus 18. Okay, now I'm going to leave that 2 out front. It's going to be my final answer, but now I'm going to factor what's left. So this is that factor by grouping. So I'm just looking at these 2 terms and asking myself, what's the GCF? I could take out an m squared, and I'm left with 5m plus 2. Here I could take out a negative 9. So I'm left with 5m plus 2. And again, the goal is I want these to match. And whatever sign is here, I'm going to keep that. Okay? So now that these match, here's how I rewrite it. So I have 5m plus 2. And then whatever's out here goes in the other group. M squared minus 9. Now, this actually factors further. That's difference of squares. That's 2 things I can take the square root of. So I still have the 5m plus 2. This now factors into m plus 3, m minus 3, because the difference of squares. And then this 2 that I took out from the very beginning needs to be out front. So this would be completely factored. I kind of used a couple strategies there. First GCF, factor by grouping, and then difference of squares. Okay, that's a quick recap on factoring, you guys, and that's it for this video. Thanks for watching.